I'm going to go through now a series of drawings to explain the basic definitions and concepts that we need to work with perspective. My recommendation would be to get some paper to take notes on, paper that you can draw along on. I don't like handing out a worksheet that has all of this information on it because I've found in the past that it's better if students actually draw along, put this down in words that make sense to them. This might be a little bit longer, but you should really put the time in on this. Take the notes and make sure you understand this, because the couple assignments coming up are going to be really hard if you don't understand these concepts. But we need to cover this. So on screen here we'll see basically a cube. And we need to have some basic definitions for talking about a cube, and that will help us with everything else that we're doing with perspective. The flat parts of the cube, the surface that you could run your finger across, those are called planes. And if there's a plane facing straight at you, so you actually have like a square in your visual field, that would be called a facing plane. Then you have edges, which are the extensions here between the corners. That should all be pretty obvious. The corners are where all the edges come together, and the planes are the things in between the corners. So we'll have all of that. Now when we're working in perspective, we always need to be working within a picture plane. This doesn't work if we don't have a picture plane, because the points that we're going to talk about, the things that we're going to talk about, are all relative to the picture plane. So the first thing that we need to define is the horizon line. The horizon line is just your eye level relative to the picture plane. So if I'm standing up and my eyes are 6 feet tall, it's kind of tall, but my eyes are 6 feet tall, this would be 6 foot tall in the picture plane. I could move my eyes up or down and keep the picture plane stable. So let's say I was 6 foot tall, but I crouched down, and then I was only half my height and I was 3 feet tall in front of the window. That could be there. The other thing that could represent is just that I stayed at 6 feet tall, but someone moved the window up, and so then my eye was lower relative to the window. I'll go ahead and do that here. Instead of changing the line, I could just move the picture plane, right? Then the line changes even though I haven't changed. Or I could come here and move the line, and that's me changing my height relative to the picture plane. So either one of those things can move. I'm going to set this pretty much in the middle. And just because a line's high up in the picture plane doesn't mean it's tall necessarily. It just means like I could be laying on the ground here, so the window like goes underneath the ground, and this is only ground level up here. It just depends on what you think that line represents. So you want to have in your mind some height that line represents. I'm going to say this is like 6 feet tall, and anything that touches that line would then represent something that's 6 feet tall. No matter how high you get, you can't get your eye off of the picture plane. Remember, off of the horizon line. We talked about that. You can look down away from the horizon line, but it'll still be there where your eyes would be at when you look back up, or you could look up and it would still be where your eyes look down. You can get up in an airplane, your eye level will still look like it's on the horizon line. Then the other 2 points that we need to be, the other things that we need to be concerned about are, let me get my pen here. We need to be concerned with the central vanishing point, and that doesn't have to be in the middle. I could step off to the side of the picture plane, or I could move the picture plane to the side of my vision. I'm going to go ahead and put it largely in the middle. The central vanishing point is just where I'm looking. I'm staring straight forward into space, and I'm looking at some point on the horizon line. And then we'll also have diagonal vanishing points. I don't want to go into in this class how you determine those. I'll just tell you where they are, but they're somewhere off of the picture plane. They definitely cannot be on the picture plane or within the picture plane. They can't be here or here. Basically what those represent is if I have a box, the top of a box that's tilted at 45-degree angles to me, that would be, I know I'm not actually aiming towards it. Let me do a better job here. That would be like where the top of the box at 45-degree angles relative to here is. That's how you get those. But you don't need to worry about that too much. So we've got the picture plane, got to have that. We've got the horizon line, we've got a central vanishing point, and we've got diagonal vanishing points. Now what we're going to do is we're going to go ahead and just draw a cube. To get the cube, we're going to just put a square in. We're going to be working in 1-point perspective for right now. What 1-point perspective is when all the planes are facing towards you. So you always have a flat, like the square facing towards you. Nothing's tilted away from you. One of the planes is facing right at you. Then what you get is you have vertical edges, horizontal edges, and receding edges. And the receding edges are represented by lines that go back to the vanishing point. Like that. Pretty simple. There's a couple rules, so go ahead and write these down. Rule for turning things into three-dimensional objects. Rule number 1 is, in a three-dimensional box, every corner, and this is, just write this down, every corner, rule number 1, every corner has 3 edges. If it's a three-dimensional object, every corner has 3 edges. So right now, I've got a 2-dimensional object where every corner has 2 edges. I'm trying to make it 3-dimensional. Rule number 1, I know I need to find the missing edges. Then rule number 2, write this down. Receding edges must go back to a vanishing point. I don't want to say the vanishing point, but a vanishing point. Receding edges must go back to a vanishing point. Rule 2A, sub-rule, is if you're in 1-point perspective, the receding edges will go back to the central vanishing point. Receding edges will go back to the central vanishing point. So I'll do that now. I'll use both rules to turn this into a three-dimensional object. So I got a square. Every corner only has 2 edges. They've got the vertical and horizontal edges on each one. So all I need are the receding edges. Rule number 2, all those receding edges need to go back to the vanishing point. A vanishing point, in this case, the central vanishing point. So I'll do that. It sounds like a lot of gobbledygook when I'm talking, but when you see it happen, it's pretty easy. All right, now I've got this thing extended back. It's not a cube yet, though. It's just like some shape that extends forever. So I got to now go back to rule number 1, and I've got edges, but they don't have corners. So I'm going to give it corners. Notice I did not do this corner. I didn't complete that third edge. That's because I don't want this object to be see-through. And this edge would obviously go back behind the box. If I wanted the box to be see-through, then I would head this line back to the vanishing point, but stop it here. You know, it's like if it was, this is called open face. But I don't want that, so I'm just going to go ahead now. Going to cycle back to rule number 1 and just put in some more corners. And for that to happen, I need to put an edge. Now you'll see there's corners back here. I've got a corner here. Now it has a receding edge and a vertical edge. So I'm going to put in that horizontal edge. And then I could go ahead and like erase out the rest of these lines. When you're working on your paper, and there's going to be a video of me doing some of this stuff on actual paper as well. When you're working on paper, don't always draw all the way to the vanishing point. I have to do that on the computer because of how the tool works. But if you draw all your lines all the way to the vanishing point, it's going to create a mess right here. You'll see I'm just going to erase a lot of it anyways, so you don't really need to worry about that. Just draw them as far as you think you'll need to go. This will work perfectly well with objects that are above the horizon line, below the horizon line. So I'll do this one real quick. Rule number 1, I'm missing edges, so I'm going to fill in the edges. Rule number 2, those edges are receding, so they go to the central vanishing point because I'm in 1-point perspective. If you look at this right here, this thing is so close to where the central vanishing point is that receding edge is almost a vertical line. That freaks a lot of people out. Don't let it freak you out. That is accurate. Just follow the rules here. And then I'm going to pick the back of it. So that's where the back is at. And then this is going to go straight down. And you'll see on this side it gets really tight. Like I can barely even see the difference. And that's going to happen if something is right by the central vanishing point. Or if this scooted down a little more to the horizon line, you would get that effect. Also here I have something that crosses the horizon line. So what you would get is rule number 1, find the missing edges. Rule number 2, make sure they go back to, in this case, the central vanishing point because we're a 1-point perspective. And then I'll just close off the back. Now I wouldn't have any third line to complete because it crosses over the horizon line, so I cannot see the bottom or the top. And in this case, I would go ahead and erase the horizon line out so I can see everything nice and clear. All right, that's the basics of 1-point perspective. In 2-point perspective, what happens is the cube or whatever shape we're drawing, whatever box shape we're drawing, turns, and we just start with an edge facing towards us. Now that we have only one edge, we're going to have to apply rule number 1 to complete 2 edges coming off of it. So in this case, rule number 2, we'll say rule number 2B, is if you're in 2-point perspective, then your receding lines, you'll have 2 sets of receding lines, and they will go to the diagonal vanishing points, both diagonals. So on the right side of the object, you'll go back to the right diagonal vanishing point. And on the left side of the object, you'll go back to the left vanishing point. Again, for right now, I'm not trying to get a perfect cube. I'm just getting a box shape. So go back to rule number 1. I need to create new edges so I get my corners. So I pick some edges. Now I've got corners. Corners only got a receding edge and a vertical edge. I need another receding edge. Notice that in 1 point I have vertical, horizontal, and 1 receding. In 2 point, the horizontal goes away and I have a vertical line straight up and down, and then I'll have each corner has 2 receding edges. So I'm also missing here. I have 1 receding edge and a vertical. I'll go ahead and put the other one. It should be pretty obvious which direction these are going to go in. If I'm coming from this point here, I can't go up and down anymore, and I can't go back to that vanishing point. I'll just repeat the same line. So I'm going to head off to the one on the left. Same here. Up and down's not very useful. Off to the left is not going to get me anything, so I have to go to the right. There I go. I've got my box in perfect 2-point perspective. And I would erase out the lines. Again, when you're working with the ruler, maybe only draw your lines like that far because you know that you're not going to go much further than that, and you don't want to create a cluster of lines over there that makes everything difficult to look at. So that's the basics of 2-point perspective. I'm not going to go into 3-point perspective. I know I talked about it, but we're never in this class going to work past 2-point perspective. So those are the basic definitions: planes, corners, edges, and then you have the 2 rules. Every corner has to have 3 edges, and if it's a receding edge, it has to go back to a vanishing point. If you're in 1-point perspective, you'd be using the central vanishing point. If you're in 2-point perspective, you'd be using the diagonal vanishing points. Now I'm going to teach you 4 tricks that are very important in perspective. So write these down just like you did the rules. Trick number 1 is how to cut any 4-sided object in half. All you have to do, like right now I don't have a ruler, and I don't know what the measurement of this box is. If it was like 2 inches wide, then it's easy enough to say, well, I'll just measure an inch and I'll put a mark in the middle. But I don't know, and I don't want to do the math on it, and it could be some really weird thing like, 2.6879 inches, and like God knows I don't want to do the math on cutting that in half. So we'll just do some very simple visual geometry, and that's all perspective is. It's just geometry without numbers, visual geometry. So to cut any 4-sided object in half, I just put an X in it. That gives me the middle of the object, the center of the object, and then if I draw lines up and down and side to side, now I've got the middle of the edges. So I've cut it in half this way, I've cut it in half that way, and I've made 4 quadrants out of it. So technically I've broken it up into 4, but I found the center of it and the middle of the edges. That's trick number 1. This works perfectly fine. I'm going to go ahead now and make like a wall. So imagine this is the side of a box. I don't need to draw the front of the box. Now in this case, say this is 2 inches and I measured 1 inch and I put that line at 1 inch. That would cut the thing in half improperly. Remember, the whole point of perspective is that things are supposed to appear to get smaller as they go back. So I can't just cut a 2-inch line in half at 1 inch, and you really don't want to run the numbers on where should you put this line. So this X trick works really great when something is not just a straight rectangle. It will show you the actual halfway point of something going back in space. So it will perfectly divide the front half from the back half, and you'll see that the front is larger and the back is smaller, which is exactly as it should be. And it's the exact amount smaller that it needs to be mathematically for it to look right. Now in this case, I can put the line straight up and down to cut it in half that way, but I can no longer go like straight across from here to cut it in half this way. Obviously this is not the halfway point of that front edge. So I need to use, because it's a receding plane, I need to treat it like a receding edge, and rule number 2, I need to go through the vanishing point. So you'll see now I've got this wall that's turned sideways, and I've cut this in half. Cut it in half height-wise, cut it in half depth-wise. So I could say each one of these is like 1 foot. This would be 1 foot tall, 1 foot back, 2 feet back, 2 feet back, 2 feet up. This would work just as well in 2-point perspective. I'm not going to waste time by showing that, but if you had a side of an object in 2-point perspective, trick number 1 works just as well. Trick number 2 is just going to be trick number 1 going the other way. And if that doesn't make sense to you what I'm talking about, just learn how it works. But basically, instead of cutting something in half, we're going to double something. So say I want another one of these right next to itself, and I don't want to do any measuring because that's just too difficult. All I need to do is I can steal the height. I know how tall it is. That's a given. And this would work just as well if I was trying to go down. I could steal the width, but I don't have room for that. So I know how tall it is. What I don't know is how wide it is, and I don't want to just guess. So what I'm going to do is first off, I'm going to do trick number 1 and find the middle of it. Notice the middle is not on the horizon line there. What I'm looking for here is I found the center. Now from here, I just want to find the middle of the edge that I'm trying to extend past. So I'm trying to create, I'm trying to create another box off to the left. So I want to find the middle of the left edge. So I'll just go to there. So far, that's trick number 1. Now, trick number 2 is to connect one of the 2 corners opposite this middle of the edge. So either one of these will work. I'm going to go from this one. So opposite corner to the middle of the edge that you're trying to extend past until it hits the edge here. Or, if you're going this way, hit the edge here. What that will give you then is a new corner. Remember, we're always trying to find corners and edges. And off of that corner, I would complete my edge. And I would have another rectangle of the exact same size next to it. That's obviously, when you're going up and down and side to side, a bit silly, because you could just take a piece of paper and like mark off right here what your size was and just repeat it. But again, if we have something that's going, I'll do another wall here. So say we've got like that image I showed with the road full of telephone poles. Say I've got the distance between the first 2 telephone poles. And then I want to put in a bunch more telephone poles, and I want to make sure that they shrink properly going back. So what I'll do is I'll do trick number 1. And this works just as well going forward as backwards. I'll do both. So I'm going to extend my telephone poles here a little bit further. I don't know that I have room for this to go forward. We'll give it a shot though. Alright, so I've treated the edge of these telephone poles like a box. I found the center of the box. I want to go forwards and backwards, so I'm going to extend that so I know the middle of the front and the back edge. Middle of the front edge, middle of the back edge. Now I'm going to do trick number 2. So I'm going to go to one of the corners opposite the middle of that edge. So corner, middle of the edge to the edge, and then extend up. Now that I've drawn this line, I've already got the middle of that back edge, so I can just keep going. Corner to middle of the edge to where it touches, and I'll go straight up. And wash, rinse, repeat on that corner. Now I've got a new middle of a back edge, straight up. And you'll see that these are shrinking as I go back, and it looks exactly like what was going on with those telephone poles on the road, that they appear to be getting, the distance between them appears to be shrinking as they go back. And this is, if you follow this process, it's really hard for me to be super accurate on the computer, but if you follow it accurately, it will be exactly the way things would look in real life. Now, I don't think I have enough room. Yeah, if I do corner to middle, well, maybe. I can do this going forward as well. I'm just running out of room on the screen, but it would be, we'll just go down a little bit lower here on the screen. I could also get another telephone pole going forward. Okay, it would be right there. So I realized I needed one more to fit into my picture plane, and that works perfectly fine. Okay, so now I have a telephone pole going forward as well. So trick number 2 works in both directions. This would work just as well in 2-point perspective. I don't need to show that. And if you're really paying attention, what's going on here is if I took this larger shape and did trick number 1, the corner of the middle of the edge that I'm using for trick number 2 would just be the midpoint of that larger X. If that doesn't make sense to you, don't worry about it. Trick number 3 is the most important one for what we're going to be doing. For whatever reason, a lot of people forget this one. So really, this is the one that you really need to know. We don't use it very frequently, but it's the most important one. so far I've just been randomly choosing the back edge of my objects, which is fine if you're just eyeballing a drawing. But what we want eventually is to be able to get an actual cube or a square going back in space, because then if I get a whole bunch of them, I can say each one of those things equals like 1 foot tall, 1 foot wide, 1 foot deep, or whatever measurement. It's just an even unit, and then I can count my way through space. So trick number 3 is getting the accurate back of a cube. This accurate back of a cube is relative to the points you've chosen, and I don't want to go into why we'll choose the points that we choose. I'm going to choose them for you, and if you want to know more, please feel free to contact me. I'll put you in touch with the information you need to be in touch with. For our sake, though, just know that given the points were chosen, this is going to make an accurate back of a cube, and it would work for any points you've chosen. There's just better or worse. Basically, central vanishing points are diagonal vanishing points. Ours aren't going to be the best, but they fit on the paper. So, trick number 3, the first thing we're going to do, I'm just going to use the rules here. So I've got a bunch of corners that are missing their edges. Rule number 1, I'm going to complete the edges, and we're in 1 point perspective. Trick number 3 doesn't really work in 2 point perspective. It just sorts itself out in 2 point perspective. Be more careful than I am about hitting that vanishing point. This is difficult on the computer. You should be being really accurate. And you watch the videos where I do this with an actual ruler, and you'll see how to be good at that. Okay, now before I was just saying, that looks like the back, that looks like a cube to me, and then I'll close it off. Good enough for rock and roll. Well, we don't want that anymore. We want to be super accurate. So what we're going to do is come from one of the 2 diagonal vanishing points, and if they're properly chosen, which they are on the paper, on the setup that I'm giving you, you just go from whichever diagonal vanishing point you're choosing to the corner opposite it. So I can't go to this corner, I need to go to this one. Where it crosses over here, that's the corner that you're looking for. That gives you the edge that you're looking for, and that guarantees now that that is actually a cube in perspective, given all the points that we've chosen. Alright, so now we've got a cube, and that's awesome, because I could do like now trick number 2 and get a whole bunch more cubes. Same thing, I'm going to go over here. Once you pick a diagonal vanishing point, stick with it. Don't flip-flop over to that one. If they're set up perfectly, it wouldn't matter, but I'm not convinced mine are set up perfectly here. So just to be safe, I'm going to stick with it. So there, I've got a cube. Come over to here, opposite corner. This is my new corner here for the back of the box, and I'll close it off. And then I've got a bunch of cubes in space. We don't know that they're all the same size. We'll get to that in a minute, how to make sure you get a grid of everything all in the same size. But that's trick number 3. It's by far the most important trick that we've got, is making sure that we determine the accurate backs of squares and cubes. Okay, so I know each one of those is a cube. Clean all that up, and I'd have a pretty picture. The last trick you need to know, trick number 4, is how to deal with circles. If you're drawing like a sphere, a 3-dimensional sphere, I'm gonna draw this real sloppy. It just looks like a circle in your visual field, no matter what angle's at. But if you have a circle like the top of a cup, and then it turns into space, it looks something like this. Those shapes are called ellipses. We've already done the ellipse matching exercise now. So you're used to drawing these shapes. And you know they're kind of difficult to get your hand to do it right. Like I always have a bit of a trouble with one side, like that side got fatter. They're really hard to predict exactly what they should be like if you're just eyeballing it. So we can come up with a pretty easy way to get it exact using perspective. A circle, let me go ahead and make an actual circle here. A circle bears a relationship to a square in that every middle of the square is exactly, sorry, I'm going to change my tool here and then I'll talk. There we go. Okay. The circle lines up within the square so that it hits exactly on the middle points. So if I do an X and then I use that to find the middle of the edges, a perfect circle for that square, my circle didn't quite fit perfectly, will touch only right at the middle points of those edges. So all I need to do to get a circle is find those edges, and then I would normally hand draw that in, but I got a tool that lets me do it more clean, so I'll use that. This works just as well in perspective. So I'm going to go ahead and take this square down here. I'm going to turn it into a cube. Can't just be some random rectangle. So trick number 3. It's actually a cube now. And I'm going to put a ellipse. It's a circle turned into perspective on the top and the side. So now we're going to use trick number 1. And that lets us find the middle of the edges. This is actually easier with a ruler because I can go both directions at once. Then I'm going to come from the vanishing point to find the middle of the edges here. Now I've got these 4 points on the top and these 4 points on the side, and all I have to do, we'll just do this by hand now because that's what you're all going to be having to do, is just as best you can create arcs that cleanly connect those points, and you've got the ellipse. There's tools that let you do this. There's templates where you can just spend all day trying to find the one that fits exactly, but for class it's enough that we just go ahead and do the best we can freehand. In Photoshop I've got a tool where I can just come in and do it real easily. I'll do that real quick so you can see a proper ellipse. Not as easy as it looks, actually. No, that's not going to work the way I thought. But you would get a shape like this. There we go, that's a little better. But we'll just go ahead and eyeball them and put them in by hand. So that's drawing a circle turned into space. It makes an ellipse. Now you also want to understand that it's not an oval. The difference between an ellipse and an oval is an oval would fit into a rectangle like this, and when you do that, each side is totally equivalent. Like when I cut it in half this way and cut it in that half this way, each slice of the pie is the same size. With an ellipse, you would see that the back slices, because they're in perspective, will be smaller. So they kind of look like ovals, but they're not ovals. Alright, that's trick number 4, is how to draw a circle in space. With those 2 rules, every corner has 3 edges. The receding edges have to go to the central or diagonal vanishing point, depending on if you're in 1-point perspective or 2-point. And then cutting things in half, doubling things, making sure you have the accurate back of a square, and being able to draw ellipses, you'll be able to do everything that we need to do on this perspective plate. Okay, I'm going to have to record another one of these videos that will show you how to get the perspective plate set up, and then I'll also provide you one that shows me doing it by hand. You can watch however many of these things you need, however many times to help you get through this assignment.